Ok, aspetta, vediamo quello. Lo mettiamo qua. Ecco fatto.
Quindi a me basta solo fare così.
Così, con le freccette.
Fammi.
Diciamo, sì. Davanti qua, a destra, ok.
Andiamo sempre a destra.
Bene.
No, okay.
So, good morning, everybody. Let's start this third day of the biological risk week. And for this morning, we have Dr. Gianmarco Ludovici. Gianmarco is a biologist, of course. He works in Thermo Fisher Scientific, and Thermo Fisher, as you know, is one of the main firms for the chemical and biological detectors. This is not the topic of the day, just to let you aware of that. Gianmarco works on the development of vaccine, basically on Moderna vaccine for COVID-19. This is what he's doing since the beginning of the pandemic. So he's an expert on viruses, fungi, and toxins, and those will be the three topics he will face with you in his lecture. Gianmarco also completed his PhD on biological risk here at the University of Rome, Tor Vergata, and he's a Knight of the Order of Knights of Malta. I have to say that because he became Knight a few days ago. Oh, Gianma, Portella.
Do you know the problem?
So he will stay with you. Good morning. Good morning.
Until 1 p.m.
Until so enjoy the lecture. For the break, you will take an again with Gianmarco. See you later. Bye much.
Thank you, Andrea. Good morning, everyone. I am just Andrea Gianmarco Ludovici. I am a molecular biologist, and actually I work in Thermo Fisher Scientific, but not in the Moderna program, because fortunately the pandemic is over. So now I work in experimental phase 1 and phase 2 drugs. Thermo Fisher is, I don't know if you know, Frosinone province. There is a big pharmaceutical pool with other company like Sanofi Aventis, Novo Nordisk, other like near like the same pharmaceutical company in Pomezia, Latina, is a pharmaceutical area, very important. And I work with Andrea. I have completed the second level master degree in CBR events 2016, and after I started the PhD with Andrea. Another thing, please, I want to know your background, and if you want, because this is the first and last time that we see, maybe we will see another time for the use of software in epidemiological, maybe I will do this lesson, I don't know, but if you want, for the final thesis, stay with me like tutor or coordinator. I give you the contact if you are a biologist or interesting to create some type of thesis. I have done this type of thesis regarding, so I let you know the topic, the use of virus or bacteria like bioweapon, and simulate the propagation of an infection in a state, in a country, and how you can management health emergency in this case. So if you are interested in this type of topic, we can talk about this, and for your final thesis, you can I give you my number or email, or you can ask to Andrea or Riccardo, Alba, or Colombo. So I don't want to bore you with a lot of information. So first of all, I want to know your background. So we can make a presentation, please.
Samuele Caruso. I come from the industry. I work at Fincantieri. And I'm a security manager with political science and the criminological background.
Ah, okay.
Michele Castorilli, di Villadino, my study biotechnology from PTSU. And I now find
So this topic, maybe you will know the information regarding the viruses and toxin and fungi. Okay.
I am Ludovici Franco. I am a warrant officer. I am duty in embassy school, Rieti.
Ah, I know.
And I am a CBR defense platoon commander in Rieti, the Netherlands.
One of my best friends is Federico Baldassi,
I know.
Fabrizio D'Amico, Gaetano Carminati, Gloria. I was my teacher, and Federico Baldassi was my co-supervisor in my thesis in the second level of difference. And Fabrizio D'Amico.
Good first.
Yeah, I know.
Morning, I'm Dario Cossuto. I'm in the Italian Army. I graduated in a political science branch, and I am on duty at the NBC school in Riyadh.
Yeah, okay.
Good morning, I'm Clementina Botero. I work as a geopolitical analyst for a corporate intelligence and risk management company, and I have a background in political sciences.
So the Shamsi, from the Emirates. I have a chemical engineering background, and I'm currently working at the Dubai Police in the CBR Incident Response Department.
Applaus. Levels and police and forensics, and I'm also team leader at explosive safety and one of the rest of civilian units for the national police. Met technical backgrounds.
The policy in Netherlands have a civilian department.
Yeah, we have a national park, national training stations.
Not likely.
The things are arranged to the end, but
Good morning. Yeah. I have a bachelor degree in genetics.
Good.
Morning, Sarah Delphi, University of Florence, Amatins.
Florence, so pizza. Okay.
Professor Manuel dynamics are very accurate.
Morning, Dr. Giuseppe Italiani. I'm a platoon leader in the 7th Regiment.
Right.
Yes.
Morning. I'm making presentation. So you are?
Ahmed Al-Nani from Dubai Police CBR.
Okay. Please. Start. So I want to, first of all, I am Gianmarco, not professor, first. Second one, I want to do a interactive lesson. So during the lesson, I will stop and ask you sentence regarding if you know, or there are a little bit question regarding the background of biological topic, because some of question that I will ask you will be in Hexa. The exam is very, very easy, but maybe the question that I will ask you will be in the exam. So the lesson, the first 2 hours, we'll talk about viruses and the potential use of viruses in like a biological weapon, and also we analyze actually outbreak, because I don't know if you know, but actually we have a Sudan Ebola virus disease in Uganda. So another Ebola outbreak, not like 2014, 2016, but the Ebola virus have a mortality rate like 50%. Another outbreak of norovirus, you know, regarding the increase of cases of norovirus in England. there is another particular aspect of this type of virus is similar to rotavirus, so gut virus, for example. Another virus that is circulating in Europe is metapneumococcus human metapneumoviruses, HMPV. It's called the virus of Giuliano. It's starting from China, obviously. And the recent discovered in China is the new coronavirus, is discovered a few days ago. Sorry?
The bets again.
Again, yes. No, so COVID was a particular virus. So, okay, I go fast and we make few stops and now we get started. So, io sapevo che andava male. Okay, this is the agenda of today regarding the first lesson. We will do an introduction to molecular biology, the biological weapon and the viruses that belong into this category. It's category A of CBC. We will make a brief, really history lesson regarding the use of biological weapon during the history. We talk a few times of the most recent viral epidemics of SARS-CoV-2, what called COVID-19. My field of study, the COVID-19 and vaccinations. So how we will talk about regarding the Moderna vaccine, so mRNA vaccine, and the new outbreak that are circulating. So, do you know how is structured a virus? It's very simple. Viruses have a protein coat. Some species of viruses have an envelope, is derivated from the cellular surface, cell surface of a host cell that infected, and inside have a viral genome. The viral genome is very simple, codify for different protein, normally structured protein and not structured protein. Is not like a DNA of eukaryotic cells, but with the genome could be RNA, negative or positive strand, DNA fragmentated, RNA fragmentated. For example, influenza viruses have 7 pieces of RNA, or COVID-19 have 1 RNA, sorry. No. It's a good question, but no. Some viruses, for example, HIV, take inside a protein, the retrotranscription protein, that can translate itself. But normally, every viruses in nature, human and not human viruses, use the host cell apparatus of replication. For example, ribosomes and amino acid. And normally, the infection is simple. The viruses have on the surface the spike. The spike protein is like a key that interact with the receptors of the host cell surface. Is virus specific. The viruses enter inside of the cells. This is a more structured imaging. Just as I say before, but the the slide, we will give the slide. So, this is the different. No, I want to show you the virus replication and after return. So this is the normal infection of viruses. The viruses attach the cell surface of the host cells, interact with the receptor, normally it's a protein, go inside, encode it. So in this case, the genome is free inside the host cells, and use to can use different way to replicate himself in base of the type of genome of the viruses. And normally use the Golgi apparatus to replicate himself, the protein, and create a lot of copy of itself and go out from the host cells. During this process, the host cell died, and the different type of viruses create the different disease. So, for example, I don't know, influenza viruses interact with the tract of the respiratory tract of the cells of the respiratory tract and give or symptoms like flu, like cold, fever, and other symptoms. This normally is in this way, but there are a lot of types of virus and different cycle of replication. So just say before, this is the normal structure of the viruses. So if the viruses have an envelope, it's called envelope viruses. If don't have this type of other layer, it's called naked virus. Nucleic acid, protein, and lipid membrane for the envelope viruses. In this other part of the figure, do you know what is a bacteriophage? What is this? That is right. And starting from this type of viruses start the molecular biology study. It's very simple. It's like a syringe. We have a capsid with the nucleic acid, and from this is like a fit on the surface of the bacteria. The nucleic acid is injected inside the cells, the unicellular cells, and in this case, the genome can do two different things, or can integrate it inside of the genome, or can destroy directly the bacterial cells. So this is the structure. So just say before, the human viruses in general have the spike protein that interact with the cellular surface. In case of bacteriophages, have this structure that can interact physically and inject the DNA directly and inside the cellular. So maybe you know this question. Do you know the difference between a viruses or a eukaryotic cells? No one says difference.
It's living.
Why? I'll say the organism says living or not living. It's an empirical question. So normal organism to say is living, is life, can replicate, born, replicate, and die. Viruses can do this? No, because don't have the structure to replicate himself without a host cells. Also, the the structure of different organelles. So, for example, the DNA or inside the eukaryotic cells is inside a nucleus. The viruses don't have a nucleus, just say like the bacteria. And all the structure, cytoplasmic, Golgi, mitochondria, other structure that can replicate itself, the viruses is a very simple and is a limit for life or not life. So it's only to see that every viruses have a specific receptor, because the spike, you can say, it's famous spike protein, is particular only for the targets of the viruses, like a key and door. Just say replication. So, very fast. First step, penetration. Viruses go inside the cells. Replication, protein synthesis. The viruses can assemble another copy of itself, release, and destroy the cells, and create a disease. So, role of viral disease and prevention. So, this is an example of type of the viruses that can create a lot of mortality in humans. HIV, that cause a syndrome of immunodeficiency acquired. The HIV, for example, is a particular virus because after the infection, the viruses stay quiet, like herpes virus. You don't die for the viruses. You will die if infected and acquire and take the disease, because the viruses destroy all the immunity cells, in the specific CD4 cells. You don't have the defense to other disease, and you will die, for example, for a flu. Influenza viruses, that is a common viruses that spread during the winter time. And sometimes it's sort of located because, okay, I take a flu. Normally, during a human life, you will take the influenza disease with influenza viruses 2-3 times in life. Normally, it's the para-influenza viruses that we take during the winter time, because the influenza.
Life.
Yes, 2-3 times. They take the real influenza viruses, because influenza viruses is a strong disease, and during immediate 14 days. So it's when you say I take a flu, the real flu is different, have a different symptoms. And this is and the problem of this we will see after, and in the particular of the genome. I just said before, the influenza genome is divided in 70s of RNA. And the problem is that if I take 2 types of the influenza, could be a question in your exam. If I take 2 different influenza viruses together, can the recombination and create another type of influenza viruses. So when you say H1N1 viruses is the combination of influenza viruses, and we create another viruses. And sometimes one is more virulent respect to other and more infective. So viruses. Now, after we will see the viruses classified as potential biological weapon. Do you know the difference of this level of biohazard? So normally the molecular laboratories, genetic or microbiology, biological laboratory is classified in base of the pathogens or biological agent that is studied. And in base of level, we have different countermeasure and structure to isolate personnel from the pathogens. Normally, a BLS1 is a university lab, like a desk, and you can use normally bacteria, like for example, Escherichia coli, or not human pathogen viruses. For example, I study rotaviruses of the monkey, for example. BLS2 is different. We have to take different countermeasure, isolated room, different biohazard protocols, and you can use glass, gloves, coats, and oven a different way to move inside the room. And here you can use, for example, influenza viruses, cold viruses, and other type of viruses. BLS3 is famous because in BLS3 you can use HIV viruses and other pathogens for human. And the most important, when you say, for example, in people that have like a switch, come si diceva, tuta di contenimento? Vabbè. Okay. In this case, BLS4, you can use different and study different type of viruses, the most pathogen, and classify with the most dangerous viruses for the human health, Ebola viruses, and smallpox. After we see that some laboratories in the world have smallpox, but smallpox, do you know, is the only one viruses and disease is eradicated in the human history. So this is the different category of agent. Is the category A, the highest priority, B, second highest priority, and C, not dangerous. Is classified by CDC, Center for Disease Control, in Atlanta, USA. So, in category A, just said before, we have Variola major, it's the virus of smallpox, and Marburg viruses is hemorrhagic fever viruses like Ebola viruses. In B, we say, for example, Escherichia coli. Do you remember the outbreak of this type of Escherichia coli in Germany? The salad infected of this type of Escherichia coli, because the problem is the Escherichia coli, this type of Escherichia coli is multi-drug resistant, but this is other topic. Also, we have cholera or Staphylococcus aureus that produce a lot of toxin, and resin. Do you know the resin? Resin is one of the most powerful toxin in nature. So one of the most studied viruses that could be used for a biological weapon is the smallpox viruses. I don't know if some of you have the scratch regarding of vaccination of smallpox. The history of vaccination starting from smallpox. Do you know how start vaccination? And why is called vaccination? Yes. Do you know why? Right? Janne, the discoverer.
People who were don't have the
Right. Just say your colleagues in this is the doctor of the Denmark crown, And during his life, see that the people that touch the cow of farm don't take the smallpox. And he say, why? Because the cow is infected by the cowpox, is similar to smallpox, create antibody to this type of viruses, and this take the idea to with a needle to take the scratch of the rush of the cow and put to scratch of the human, and during the 18th century start the vaccination. But the smallpox is very particular because its property is the high mortality rate, and actually is eradicated because World Health Organization in 1981 or 82 declared smallpox eradicated, because to say if a disease is eradicated, no cases in 4 years, more or less. And smallpox, after the vaccination campaign during the 60 and 70 of the 20th century, fortunately was eradicated all over the world. But 2 laboratories, one in Russia, one in the USA, have some smallpox to study it. And if I release smallpox is a high mortality and high velocity of spread, we can create a real outbreak, and 60% of population could die in few times.
60% of
60%, yes.
of the world
Yes.
population.
But it's not the most dangerous. Sorry? So so you see, after I just talked about this. Okay. Do you know this type of viruses? Do you know the name? This is the Ebola virus. Ebola is the name of a river in ex-Zaire, Republic Democratic of Congo, and is dangerous viruses because first of all, it's classified as category A of CDC. We don't have vaccine to this type of viruses, and have rapid spread and high mortality rate. Some Ebola viruses, because there are a lot of types of viruses it's called in the name of discovered, but normally in the center of Africa, Uganda, Sudan, Ebola, Zaire, Congo, and Sierra Leone. They are different, but the particularity of these viruses is the high mortality, and fortunately, can spread not like smallpox in airborne or droplets, but the particularity that can spread only by contact, by fluids, in the specific by blood. The problem of the outbreak during the 10 years ago, 2014, 2016, in Sierra Leone, Uganda, was that the local people don't wanted the help of the other country, and also the velocity of spread regarding that during, for example, the funeral, is people touch the body of the dead for his culture, and is the way of spread. and in this case created a mortal pandemic.
The Ebola not presses in the air.
Fortunately not. Is sorry, only yeah, like HIV. HIV you can take on the sexual transmission, right? The Ebola virus, if you touch the body fluids, for example, saliva, blood, sperm, also the vomiting, yes.
Eating gorilla bodies.
Not eating gorilla or fruit bats, because the reservoir of the viruses, this type of viruses, is the fruit bats, like COVID. Fruit bats is normally a reservoir of a lot of viruses. Thank you for the assist. Because the immune system of fruit bats is very strong and can isolate in a particular cell this type of virus. The problem is not the animal. The problem is when I encounter the animal, I touch the blood. Or, for example, this is debated regarding this, but the way of spread of HIV that start the pandemics was that for culture of Central Africa, when I hunt animal, I don't know why, but take the blood and cover the body of blood of animals. And this way is the problem that the spread of this disease. Because in a particular country or in a rural part of this country, the medical doctor or the recover people ask to shaman or I'll say Christ, okay? So this is the story of Ebola viruses, but I don't want boring you of this. And the problem of the use of Ebola viruses in the use of Ebola viruses like a biological weapon is that some people can go to this country. I'll say is in the past this was this episode that people go to the Zaire, Congo, and take sample of bloods infected and use this like a biological weapon. But we will see it's after. So this is the a few examples of the use of biological agents like a bioweapon. So the most famous, one of the most famous is Roman that do you know and we talk about after the Amanita muscaria, the mushroom, the fungi, the Super Mario viruses that red with white tip. So is a toxin because the toxin inside of this mushroom can destroy your liver. Okay, during the Roman Empire, they put the harrow inside of the scratch Amanita muscaria and use the harrow to against the enemy. So if you are brushed with a harrow, okay, you don't die for the harrow, but the toxin inside your body can kill you. Another one, and for me is the most strange but important, is the Sage of Kaffa. Sage of Kaffa is a city in actually Crimea, and was a Genoese colony. So Mongolian take the people infected, died people infected with plague, Yersinia pestis, and with catapult put the body inside this city to use plague like a biological weapon, and they win. They win with this strategy. Other is during the American-French War and also during the American-British and American War for independence, some soldier of the British Army give to, I'll say, India blanket infected with smallpox, like a gift for peace, but European have the antibody to smallpox, India not, and destroy all the population. Other, so most famous is after the 11 September is the letter with Bacillus anthracis inside the US Mail Post. Is considered one of the most recent biological attack. So this is the. So this is important. I just mentioned it. The Aum Shinrikyo, do you know? Was a cult of sun in Japan, mystic, okay? And in 1995, released a sarin gas in Tokyo subway. But someone, a lot of people doesn't know that during that day, this terroristic organization make another terroristic attack and release in Tokyo a lot of quantity of spores of Bacillus anthracis. The fortune, lucky, of the Japanese was that during the day was a sunny day, and UV radiation of the sun destroy the Bacillus anthracis spores, because if could be a rain day like today, or with cloudy, the spores could be infected a lot of people. Also, another biological attack to control the quantity of rabbits in New Zealand. Some farmers spread the hemorrhagic fever similar to Ebola virus but for the rabbits to destroy the population of rabbit in New Zealand. No, the spread was controlled, because when you see a few cases, the World Health Organization and veterinary isolate the zone, but is the mentality to use this type of this. So this is other history. This natural outbreaks. It's not whole. So influenza. Do you make a stop? Coffee break? Okay. After we talk about influenza and the way of influenza or Ebola is the candidate to be a biological weapon. Questo annoiare? Fare una cosa. Fare male più di farci. Ho detto il box, non penso capire. No, perché l'ho detto in latino, ma non la mai. Io non ho fatto, non ha detto il vocabolario che non trovavo, perché la box non capivo.
Sì, magari lo finito, no? Teresa, sì, spiegava che spreco il bassissimo saltato, se non ha funzionato, perché in realtà lì, in quel caso lì, le spore avevano ricavate da in qualche modo spore con materiale.
Come funziona? Allora, perché dice che il suicidio vuole essere per forza messo in modulare per essere distruggere. La spora, io lo faccio cosa mi la spora per io faccio noi utilizziamo quindi se distrugge la mente ok dobbiamo fare però se tu vuoi un po' di
Anche la pressione, certo.
no, passa la temperatura i lati e poi porta la temperatura però si vogliono rendono ancora più grandi scusami per distruggere la piscina cosa che ammazzano le palle la sera in altri poi la pelle niente come comuni questo dice di far pulire la roba di sterilizzare per le marmellate fatte in grande sono quelli comuni perché tu puoi pure ammazzare il batterio ma se lui ha prodotto la tossina e ce l'hai dentro la marmellata nella conserva
Basta così.
ma no, dimensione cioè la tossina botullinica presenta è un schema una che tanto usa le cose stanno no si calcola in base all'LT no? La lethal dose cioè quanto te ne serve per ammazzare la metà della che siamo 4% che serve per ammazzare il 50% ma tipo un nano serve una cosa proprio
Ridicola, cioè tipo che gliela metti nella banana
sei fottuto sei proprio morto sei morto proprio
sono difficili da creare, cioè
e tu ci pensi bene, ma se te sviluppi in casa?
è quella la cosa drammatica.
Cioè, là ci sta
una bomber della situazione che invece che mettere bombette si mette a
guarda, sai che l'ha fatto così? Sai che l'ha fatto così, che ci ha provato? Con la ricina.
Con la ricina?
La ricina, sapete? L'olio di ricino, il ricino,
Sì.
è una pianta che si trova comunemente. Teresa, scusami se faccio soft topic, sicuramente aveva parlato del fatto che se prendete, non so, tipo una zolla di terra qua e la ricucinate, ci trovate spore di Bacillus anthracis. Perché qual è la cosa? Bacillus subtilis, Bacillus anthracis, Bacillus thuringiensis. Teresa è stata mia prof anche lei, abbiamo fatto pure degli articoli insieme. Lei sicuramente va a spiegare il fatto che se io prendo il plasmide dell'anthracis, lo metto in quello subtilis, che lo troviamo qua sopra,
anche lui cambia i plasmidi, cioè le
se tu trovi qualcuno che sa fare a livello di biologia molecolare, un attimo, cioè quello della ricina, una volta aspetta, chi cacchio ha fatto questa cosa qua, che ci hanno fatto pure un film sopra, dell'ossa di pesco, la sapete, che dentro c'ha l'arsenio, il pesco, la pesca.
c'ha l'arsenio nel...
Stava un film una volta uno che tipo uscito di prigione si è voluto suicidare, se riusciva a trovare perché mangiava tutta la roba da classica, poi ci davano una pesca al giorno, lui voleva una pesca al giorno, lui tutti i giorni apriva sta noce, ci metteva una goccetta di non so che cosa e ricavava l'arsenio dalla noce. Dopo tipo anni ha preso una tale quantità tale che si è riuscito a ammazzare. No, quella è una cazzata, una cosa del film, però c'è quello. Questo poi parliamo di tossine. Dei virus è un po' più difficile, ma dei virus il problema di fare una cosa del genere è la riperibilità. Questo succede, quello che vedremo un po' con l'influenza, perché è roba che succede naturalmente, e lo vedremo poi, perché noi abbiamo la viaria, no? L'avevi visto tu prima, hai detto il 60% è tanto, la viaria fa il 90% dei mortalità.
La viaria?
La viaria, vigra, visto il film, io sono leggenda,
sì.
Quello.
La viaria, certo.
No, sono leggenda quando loro modificano.
No, diventa zombie.
Diventa sempre, no, muoio, no, dice che il 90% muore
Io sono leggenda, diventa un zombie.
L'uso leggenda, se ascoltate bene, dice il 90% muore, perché quando parla di Dio, no? Dice qual è Dio? Direbbe che uccide il 90% della popolazione, l'1% sopravvive e l'altro 9% diventa così. Quelli, diciamo, quelli sono tipo umani, però ammalati, tipo zombie, sta qua. Quello era un morbillo modificato per uccidere i tumori. C'è un virus specifico che uccide i tumori, una cosa fighissima. È stata scoperta naturalmente negli Stati Uniti, una cosa del genere.
E uccide tutti i tumori? Muore.
No, lo trovarono per caso, cioè ci fu una contaminazione di un virus in delle cellule.
Caffè freddo.
Andiamo a prendere un caffè se mi sto sentendo male. Ma ci mettiamo, fai? Io perché non so che.
Will need to stretch your legs. No.
E questo per la parte domani, è una difficoltà da fare. Ho capito, va bene. Si ripete comunque dentro. Parlo con naturalmente, no, siamo il massimo che posso dire è i bambini, sì, sapete, difficoltà. Sì. Poi il concetto che si deve prendevo sul master. Guarda che sei brigante di prendere male. Le altre basta. I fondi pubblici. Quanto? Non ho capito. No, vabbè, contate critico pensieri poco. Ripeti, faccio le cose. Adesso è sicuro che dovevi entrare in questo.
Prima delle paste, lo scorso costa tipo 8.000 euro. Chi? Di andare. No, sì. Guarda, te la grazie, di questa guarda. Really? Sono stato, con voi sì. Oggi ragazzi, non è ah, perché il mio inglese non è perfetto. Federico ci ha abbandonati come Italia. Ma è Roma, Federico. Beh, merito. Quando via, no, lui è di adesso, i pedi non sta Roma. Vabbè, io lo so, qua sta mio nome. Se sarà un Dio o un ministro Farese era no, no, esatto, io so che l'ambulatorio sta in Torre Falpa. Poi io la settimana scorsa, mito vero. Mito. Maria faceva la visita di soltanto 30 anni. Vabbè, sono cresciuto, diciamo. Il cambio sia il tuo Viene in malattia, viene e poi le rete di Federico, il professore. C'è il legato. Federico sta attendendo il mezzo. Ma maggiore sicuro.
Amico invece? Fabrizio?
Federico non lo so. L'anno scorso Pazzella lo so.
No, Benigni al settimo.
Ma che sa che terzo?
Classe del mio mandante di compagnia sta benissimo.
Perché poi a vedere, ma la scuola più ufficiale.
Un mega per master pure il Mollone, Ludovici. Oh, ma era una.
Ti capito? Diciamo di tenere. Io, ma tanta gente che ci sono legati.
No,
Adesso sta male,
Figo.
non so se c'è la di noi per il test. Mi sa che lo sta procedendo.
Mi dispiace. So, let's start.
Poi torna setti. No,
Adesso però ho fatto nel 2016.
sono tutta quella gente.
No, anzi nel 2015 ho fatto.
Parliamo di gente
10 anni fa, a marzo sono 10 anni. Ho fatto.
10 polloni.
Pazzo, vero?
Non raccomando. Sei stato pure con
Mitico,
nostre,
mitico. Lui e Benigni quando stavamo insieme a un bere a mercato la mattina da strada andavano a correre. Vabbè, fisico proprio.
Ancora così.
Sta...
Mimo è così.
Lui.
Benigni, vabbè, sai una bicicletta lo sa.
Stato. Vabbè. So,
Negli anni passano.
So now we talk about the influenza viruses. Flu is, in my opinion, the most dangerous possibly outbreak in the future. Yes. Sì. Normally, I work at the virology lab in the University of Rome Tor Vergata. So normally, the viruses is not stocked in viruses. So but in the vial. So you can use or cell infected in -80 in nitrogen liquid, or depend of the type of viruses in stock vials with medium that for cell culture, and depends of the biosafety level of the lab. We have different stock viruses. So normally you use the stock virus for research or for diagnosis. So for example, Spallanzani Hospital is one of the 2 labs in Europe that have the BLS4 classification. The other one is in Munich at Robert Koch Institute in Germany. And the only lab that can manipulate this type of viruses BLS4 like smallpox or Ebola. So do you remember during the outbreak of Ebola that the Italian doctor is transferred from the Guinea to Rome with the Italian aeronautic inside the bubble, because the Italian aeronautic is famous in the world for the countermeasure of biological containment. And Italy and Italians have a a good tool to prevent this type of outbreak respect to other country. But we have to invest a lot in research in respect to Netherlands or Israel or USA or other country. So flu viruses is classified in base of two proteins of membrane. Neuraminidase, Na, hemagglutinine, HA. So when you call a flu virus H1N5 is in base of the type of the molecular structure of these two types of protein that are in the surface. This is a spike protein of influenza, right? So influenza viruses belong to the Orthomyxoviridae Latin family. Influenza viruses are envelope. So you remember how to say envelope viruses? Mandante. Sorry. When I say that I have envelope viruses, why it's called an envelope? Envelope.
It's about an envelope.
Coated with a protein layer.
It's not protein, it's a mix. It's derived from the host cell that have infected previously. Okay? Influenza viruses can be in three types, A, B, C, and D, but it's very rare. Read this. In a typical seasonal epidemics, influenza, all over the world, we have between 3 to 5 million of infected people, millions. And normally, every year for influenza virus, die 500,000 of people. Normally, with a seasonal, okay? In Italy, 10,000. Also not derived from the viruses. We have people sick or aged, and also the viruses give the colpo di grazia, okay? I don't know how to say in English. So this is the most typical classic influenza illness characterized by 5 or 3 days of fever, bones sick, and other normal common symptoms, but is very strong respect to a cold.
3-5 million of severe illnesses.
Yes.
What?
Severe depends of your organism react, but normal infection. So I take the influenza and you. We say, for example, 10 days at home, you only 5.
Yeah.
Depend of the organism, but normally the infection is.
And what's the mortality rate of influenza?
Mortality rate depends on the type of viruses. So the number, the 500,000 I just said before, is not related only to the viruses. Do you remember during the COVID pandemics, we say the people died by COVID? No, it's not by COVID. Because when I say I died by influenza, I am a health person, I take the viruses and die. But if I have a cancer or other problems, the viruses give me the final hit, the final punch, okay? So depends. So the words make different of the situation, okay? So for example, the mortality rate of the avian flu, the real avian flu, is up to 90%, 90, not 19, 90, okay? In this classroom, only 1 by 2 can survive. So one of the one of the most most important outbreak in history of the influenza virus is the Spain flu. Do you remember? I say during the First World War, 500 million of people and 50 million people died by this type of influenza. And Spanish flu, starting from the USA near Boston, was an avian flu. And actually, in 2014, this is for your curiosity, using of the, say, climatic change, the permafrost in Alaska and in Groenlandia give us the body of Inuit infected and died by influenza virus. And Netherlands research sequencing the whole entire genome of the Spanish avian flu. So in this case, the problem for the biosafety and biosecurity and for your first and second responder that you will do is if the bioterroristic have the sequence, is like a recipe, and I can reproduce this type of viruses and I can spread. Can you imagine the dangers of this? So for example, good research, it's okay research, it's okay improve our knowledge. But in some cases, we have to stay in a way that, okay, I do this research for humanity, but some people don't think in this way. And the problem is this: no, how can bioterroristic or terroristic could be think? So this is the, you can read only for your knowledge. So this is the Ebola virus. This is the whole Ebola virus outbreak, starting from the first in 1976 in Zaire, and actually, because actually into 2025 we have a Ebola outbreak in Uganda. The type of color depending of the type of viruses, because Ebola viruses have 5 species, depending of the starting the outbreak. Only for the history, between 1979 and 1994, there was no Ebola outbreak. But starting from this year, every 2 years, Ebola outbreak start. This is the mystery. So this is the time machine of the Ebola virus outbreaks. The last Ebola outbreak in history was reported in 2014 and declared over by the WHO on 2016. 2 years of our outbreaks is the most dangerous and the most particular outbreak. I'll say before regarding the how it spread and the high mortality rate of the viruses, of this type of virus. Oh, this is my favorite. So, SARS-CoV. Do you remember the first SARS? 2003. Yes, discovered by an Italian doctor in Hong Kong, and is in the same family of coronaviridae of the SARS-CoV-2, the COVID-19 disease. But how lucky was that the spread of these viruses was very low respect to this, because the mortality rate of SARS, more or less 10%. Imagine if I can combine this mortality rate with the spread of COVID-19.
Yes.
700 million people in the world died. So it's particular. Fortunately, SARS was contained. Another one is MERS. Do you know MERS? Middle East coronavirus. Yes, in Saudi Arabia, right? Is like SARS or SARS-CoV-2, is a zoonosis. Do you know when I say zoonosis? Zoonosis when the virus is starting from an animal and can infect a human. Because the virus, respect to other organisms, can replicate itself very quickly, rapidly. So can mutate it, and in this case, starting from a camel and infect the people. Normally, a zoonosis starting from a very close, people that live close to the animal. In this case, the caravane, okay, the people that live with the move inside the desert with camel. Also, SARS-CoV-2 is start because people stay close to animals that are reservoir of the virus, okay? Or heat, for example. When the viruses enter inside the body of human, normally there are two ways. Or kill the human, the person, or live with him quiet, or can mutate itself and can spread human to human. This is the final stage of the zoonosis, and there is the problem. In this case, there is a real problem, and the problem of avian flu. We said before. MERS, fortunately, don't have have a high mortality rate, but like SARS-CoV-1, not spread in fast.
But the SARS and the MERS are starting.
No. SARS is the acronym. MERS is Middle East Respiratory Coronavirus Syndrome. So is different viruses, but belonging in the same family. A coronavirus. Okay?
Okay, thank you.
Coronaviride. A coronavirus. So, for example, coronavirus, we have 5 families. 3 is like a cold. Coronavirus is not a novel virus. We take coronavirus during our life a lot of time, but we confuse them like a normal cold because the disease is the same. Okay? But if you take, because when you have a cold, you don't go to hospital. But normally, if I go to hospital and take the swab, I can show that it's not cold. Cold, for example, have 90 types. 90 types. Okay.
All viruses.
All cold, yes, is a 90. Okay. Oh. So, very quick. COVID is not the virus. COVID is disease. Coronavirus, disease 19. The virus is SARS-CoV-2. Okay? We have to. Okay, no, I take COVID. No, you take the SARS-CoV-2 viruses. COVID is a disease that spread after. So it's a normal envelope of coronaviruses. with RNA, with envelope, with a protein coat envelope. Inside the nucleic acid is RNA, and were first detected in China in December 2019 and spread directly to other countries across the world very, very fast. The World Health Organization declared a public health emergency of the international concern in 3rd of January of 2020 and defined this pandemic, these viruses and the consequent disease a pandemic only 11 March of 2020. I don't want to bore you with the COVID. You can read this on web, but the thing that I want to tell you that the official data is that 44% of the human population contract or making contact with the COVID SARS-CoV-2. This is the how sorry for the it's not a publicity, but is how say mRNA vaccine works. So in this case, we have a lipid membrane that inside there is the mRNA that codify the spike protein of the virus. Normally when I make an injection, the lipid go inside to the cells. The mRNA using the ribosome of our cells and produce only one protein, is a VP7 in this case. mRNA or other biological drugs don't interact with the human DNA. I don't know why some people believe that this could be, but it's not true. The protein codified go outside from the cells. By our body is recognized like not human protein, is attached to our immune system and create antibody to the protein. So when I keep in touch with the viruses, I have the antibody to the protein that stay in the surface of the viruses, and normally the probability of the contagion of viruses low drastically. Okay, so the problem of the concern and the problem of actually is the avian flu. I try to explain, not read, but it's more simple to say this slide. So, what is the problem of the avian flu? First, the high mortality rate. But do you know, avian flu is a flu or influenza variant of the birds. Okay, normally birds. We are not birds. So we don't have the protein on our cells on the surface that viruses can attach. Okay, this is clear? Good. You can ask me, and why some people take the avian flu?
There's an information. Then
You also
Che faccio qua? Boh. Io? No. Sì, però non c'ho il coso. Come stavo a fare? Eccolo qua.
Gianmarco, non sentiamo l'audio.
Adesso?
Adesso ti sentiamo.
Che bello, grazie Colomba, sorry. Adesso che questo. Sorry, I see someone asked the question before. Sorry, Oh. Okay. Sorry, Colomba, but I didn't see the chat room when I stay in presentation.
Okay, don't worry, Gianmarco. We will take care of this part.
Okay. Thank you so much. And sorry again. So, the other problem that use toxic like biological weapon are that produce a large quantity to use. You have to create a factory like with biogenerator. So you have to create a large program, and a bioterroristic associate organization is difficult to create a large quantity. But if I take a small amount of quantity, also I can generate pain and public panic. The most interesting toxin currently considered a biological weapon agents are botulinum, resin, saxitoxin, and resin are currently in the Schedule 1 of the Chemical Weapon Convention. I read a few years ago in Germany, in a house, some people in a family take a lot of resin beans and to collect a small quantity of resin to create a terroristic attack in a little town in Germany. It's easy to create it, but to create a very dangerous big attack, you have kilos of toxin, and it's difficult to create. Box.
People
Yeah.
in bottles
Yes.
and they have the problem of the biological weapon.
Yes.
To be protected.
But the Botox that use in aesthetical medicine, it's very, 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 very diluted.
Yeah.
Okay.
The producer.
The producer is under the policy of FDA, Food and Drug Administration. It's I can sell these drugs in a pharmacy, for example. This is the way to control. is also go to la filiera, I say in English, is a pharmaceutical company, hospital. Stop. There is intermediate.
In the legal market.
Okay, right, but yes. No, I have understanding the question is I can buy the bottle, okay, no, but if you, for example, maybe sometime in television or journals say that people eat not controlled food, make homemade and take a botulino and die. Clostridium botulinum, like Bacillus anthracis, are bacteria that you can find normally in the soil. The problem is how can take this sample and create a larger amount of this bacteria and also extract a large amount of this toxin to use for intentional use as a weapon. The question is good, but the answer is you have to have a laboratory and to extract this type of protein, you have to buy specific materials, and the control of authorities is pay a lot of attention on this. Do you remember, for example, the attack in Norway during a man that buy a lot of quantity of soil fertilization that, but the authorities unfortunately don't block the attack, but the way to found the terrorism man was go back and found the way out is by a lot of these components that stay phosphoric and other chemical compound that created this bomb. It's easy to find and extract this. It's very, I say it's very difficult. But after, if you are a person you don't like, you can give the dragon cell. But a few times ago, no, 2 years ago, I found a bottle with Clostridium contaminated. It's easy. When you remove the top, it's like to open Coca-Cola. You say, shh, is the oxygen and anhydride carbonic that produced by bacteria and they go outside of the container, the gas. When you open and find soap or the other, and you hear this sound, trash it. You found a contamination of probably Clostridium or other bacteria. Okay, so the term mycotoxin was coined in 1972 in UK when 100,000 turkey died and was called Turkey X disease. In few words, these turkeys eat contaminated food. And there found this contaminated food by a fungi and discovered this protein. Other outbreaks of mycotoxin was discovered in Africa and in Europe, and but in this slide we see the after mentioned intentional attack when Soviet army use T2 toxin against the oppositor in Laos, Cambodia, and Vietnam during and after the Vietnam Wars. I leave you with this funny slide. All mushrooms are edible, some are only once, because you will die. So thank you for the attention. This is a list of publication if you want make and deep the arguments. If you have question, I give you another time the I give you, sorry, my contact, and if you want, you or your colleagues, me, sorry, for the supervisor or co-supervisor in your thesis of master, we can focus against epidemiological use of software of epidemiological models, for example, STEM or other one. And I am we can see and we can prepare an argument to propose to Andrea, to Professor Malizia, and try to create a good thesis for your discussion. If you have a question regarding biological weapon, virus, mycotoxin, toxin in general, I'm here, or we can stop the lesson and we see and go to lunch, and we will attend the Professor Cavalieri d'Oro for the afternoon lecture. Okay, thank you for your attention.